Hey guys, in this video, I'm going to talk about a field that seems to be taking the world by storm. I mean, this field is probably one of the fastest growing fields of research that I can think of in microbiology and immunology. And really what we're talking about here is the gut microbiota. Everybody seems to be interested in this one these days. How your gastrointestinal health seems to be directly related to the microorganisms that live there, and we're really just barely beginning to get an appreciation for how important these little bugs that live inside us are to our health. And it seems to have ramifications on everything for not only your GI health, but your intelligence, cognitive functions. There's a whole concept surrounding the gut-brain axis that's becoming really important. Cardiovascular health. I mean, really, the more and more we learn about it, the more important it seems to be. And that was, well after everybody decided they needed probiotics and Jamie Lee Curtis started sitting on a couch and telling people to eat yogurt. So in this video, I'm just going to barely scratch the surface of the type of organisms that live in the microbiota, that make up the microbiota of your gastrointestinal tract. And I'm also going to introduce some concepts of kind of chronic and long-term clinical diseases that affect the gastrointestinal tract. All right, so as I just kind of alluded to, the microflora within our gastrointestinal tract play incredibly important roles in our health. It's long been appreciated the role that they play in host defense, so the role they play in protecting us from basically infectious gastroenteritis. And also the role that it plays in digestion. I mean, these organisms are good at breaking down food and helping us metabolize different products and also helping us with our nutritional requirements. The types of organisms that are found in your gastrointestinal tract and the amount of organisms that you find in the gastrointestinal tract varies by location. And I should also point out that this video is literally talking about organisms in your gastrointestinal tract. This doesn't mean that some of these organisms wouldn't be found in other mucosal sites, for example, in the vaginal tract or in the respiratory tract, or that it wouldn't be part of like the commensals that live on our skin. But in this video, I'm strictly discussing gastrointestinal tract microflora. We actually have microflora that live all over our body. We are actually more bug than man if you take it just on straight numbers. But in this case, we're just talking about the GI tract. So I'm going to kind of start at the top and work our way out, okay? So starting at the stomach. So I don't think many people really think about the fact that there are actually bugs that live in the stomach. I think we kind of, begin thinking about the stomach as an area of very low pH. And it's so acidic, what could possibly survive there? Well, actually, a lot of things survive there. There are approximately 10 to the third colony-forming units per ml in your stomach, so that's quite a lot of organisms. The predominant organisms are going to be organisms that are able to survive the harsh pH of the stomach. And think about it, any organism that lives at any point in your gastrointestinal tract past your stomach had to survive that pH somehow. It had to get through, okay? So the predominant organisms are actually Streptococci, Lactobacillus. So Lactobacillus is actually the organism that if you are taking a probiotic, it probably does have a lot of Lactobacillus in it. There are also different types of fungi that occasionally live within the gastrointestinal tract there. And then you're going to have what I kind of call the oral anaerobes. So these are organisms that, we tend to ingest or live in our oral cavity in some way that then can make their way down. A big one for this one would be Peptostreptococcus, Fusobacterium, and then the other one that I want to point out here is Bacteroides. Bacteroides, I typically talk about later in kind of a medical education. It tends to be something that I associate with complications because while Bacteroides can live very happily in your colon, it is also, and in your stomach, it is also a mechanism for abscess formation and intraperitoneal infection. So I'll talk more about Bacteroides, and I have kind of a separate video to talk about Bacteroides, but Bacteroides is one of the organisms that is found in the stomach. As I already mentioned, the major host defense is basically the low pH of the stomach. So this defense can actually be broken in a couple of different ways, though, which promote the growth of microorganisms within it. So one way to break kind of this low pH defense is gastrectomy. The other ways to think about it are frequent antacid use, okay? So part of the reason our stomach has such a low pH is that we have significant acid production, right, within the stomach. That just makes sense, all right? But if you have heartburn and you're constantly, you know, popping those antacid tablets, eventually you're going to manage to increase the pH in the stomach. When you increase the pH in the stomach, a wider variety of microorganisms are going to be able to survive in that environment, all right? All right, so that's the stomach. Now let's move on to the small bowel, okay? So the small bowel, small intestines, so somewhere in and about here. It has a similar makeup to the stomach, pretty much until you hit the distal ileum, okay? So once you've hit the distal ileum, then we see a little bit of a change. And the real change once we get to this area is that we're going to see more anaerobes and more gram-negative organisms. Now, as I already talked about, there are some gram-negative organisms and anaerobes that live in the stomach. But what I'm saying is that as we go further into the gastrointestinal tract and oxygen becomes more limiting, we're actually going to see kind of a shift in predominance, okay? We also are going to see an increase in the amount of organisms that live in the small bowel, okay? So the number of organisms in the small bowel is about 10 to the 5th to 10 to the 6th CFUs per mil. In this case, there's kind of a couple major host defenses. The big major host defense is that we have a change in pH. So remember, in the stomach, it's a low pH, somewhere around, 2 to 3. By the time you reach the end of the small bowel, that pH can be as high as 11. So you need an organism that can get through this, acidic whiplash that it has to survive. So the pH actually acts as a microorganism selection tool because organisms will survive at the pH that they like best. The organisms are kind of moved through the gastrointestinal tract and kind of contained by the tight junctions of the epithelium. Because remember, your gastrointestinal tract is essentially a tube, okay? One long tube from mouth to anus, all right? Organisms are allowed to live within the tube. We want them there. They help us with host defense and all sorts of other things. But outside the tube, that is where the host resides. That's where we are. And that we don't want microorganisms in. When the microorganisms leave the gastrointestinal tract, that's called leaky gut or gut leak or something along those lines. And that's actually where we can get intraperitoneal infections, abdominal infections, sepsis. So that is the opposite of what we want to have happen, okay? All right, so we're going to move to the last stage. We're going to go to the colon. The colon actually has the highest amount of bacteria, 10 to the 9th to 10 to the 11th CFU per mil. In this case, though, we're really, really looking at anaerobes, okay? There's going to be about 10 to the 4 anaerobic bacteria for every 1 aerobic bacteria. The main organism that we're going to find is Bacteroides. That's kind of the most frequent organism. But you might also see Bifidobacterium, Eubacteria. You'll also hear some of the other ones that I've talked about, like Enterococci. So Enterococci, Faecium, and Faecalis are in there. Enterobacteriaceae, E. coli, you can find that in the colon. So some of these other organisms that we expect to be, normal mucosa, this is where it's normal for them to be. When they leave that area, that's when they cause disease. Colonization of your gastrointestinal tract in general, but including the colon, actually begins pretty much at birth. And part of the reason we can tell this is that you can do studies that basically show that the colonization of the gastrointestinal tract of an infant born by cesarean section versus an infant that was born by vaginal delivery is very, very different, okay? So at 5 to 6 days, a full-term vaginal delivered formula-fed infant will have largely anaerobes, and 61% of them will be Bacteroides fragilis. For those infants who went through the sunroof, i.e. cesarean section, only about 60% of those infants will have a full complement of anaerobes at 5 to 6 days after birth. What does that mean? Basically, it means that they are delayed in their gastrointestinal microbiota development. And so only 60% of them will actually have developed this microbiota, and only 10% of the organisms found at 5 to 6 days post-birth will be B. fragilis. So that kind of gives a huge indication of how, you know, our method of just even coming into this world affects the type of organisms that will show up in the gastrointestinal tract. Okay, so I'm going to do a little overview of the clinical diseases in the gastrointestinal tract here. And then if you look on my channel, I'll have other videos that focus on IBS and IBD and ulcerative colitis and Crohn's disease and celiac and all of that, okay? So just as the gastrointestinal microbiota can play a really huge role in maintaining our health, they can also play a role in disease, okay? So we're going to discuss a couple of different conditions. The first one I want to talk about is small intestine bacterial overgrowth, okay? This is a clinical condition where basically you have too many organisms in the small bowel. It means exactly what it says it means, okay? So what happens is commensal bacteria help you digest food, but when they're digesting food, they actually produce gas. And as anybody has probably experienced, when you have increased gas, you have increased bloating, which doesn't feel good for anyone, okay? If you have bacterial overgrowth, you can still get diarrhea, gas, and bloating. And this is associated with a couple specific conditions. So small intestine bacterial overgrowth is one of those conditions that we kind of associate with other diagnoses or other practices or behaviors, okay? So a patient with cirrhosis, they are more likely to experience small intestine bacterial overgrowth. Additionally, this small intestine bacterial overgrowth is associated with malabsorption conditions. This can be a bit of a chicken or egg scenario. So do you have malabsorption because you don't have the right bacteria to help you digest and absorb, or did you already have a malabsorption issue and now the wrong bacteria are growing too quickly? It's kind of a difficult thing to figure out. Chronic malnutrition will also lead to small intestine bacterial overgrowth. So just like I was saying with malabsorption, if you're not eating the right foods, eating foods is part of how we seed our gastrointestinal tract. So if you're not eating, that's kind of a problem. If you've had a significant small bowel resection, you've pretty much disturbed the ecology of your gastrointestinal tract, okay? And that can lead to changes in the types of organisms that grow. So it's kind of like introducing a new predator into the wild. You're going to change the type of animals that live there. Same thing goes for your gastrointestinal tract. The other thing that could lead to it is basically if you've had abdominal irradiation. And kind of same thing here. You've killed off a bunch of the organisms that normally live there, and now something else is growing back, and it's growing back out of order, okay? So what we most often see with small intestine bacterial overgrowth syndrome is basically that you have colonization of two organisms, coliforms, or two types of organisms, and enterococci. these are associated with some abnormalities, but when you have anaerobes becoming a larger part of the small bowel flora, especially associated with like stasis, then you have significant intestinal malabsorption. You can also have fat malabsorption. So fat malabsorption, this is a pretty common abnormality. So with fat malabsorption, you're likely to see a patient that is going to have like some steatorrhea. So with fat malabsorption, we're pretty much expecting that there's been some sort of deconjugation of bile salts by anaerobes. So your main culprits here are basically an overgrowth of Bacteroides. So everybody has some Bacteroides, but this has too much. Bifidobacterium is another big culprit for that. The Enterococci and Clostridia all have this enzyme system that's going to mess with the conjugation of bile salts. Okay, the last one I'll talk about is B12 malabsorption. This is another thing that we associate with overgrowth. Basically, B12 often will bind to bacteria instead of host cells. So if you have too many organisms growing in your small intestine, those organisms are going to eat up the vitamin B12 before you can. So you wind up B12 deficient because your microbiota is eating your B12. Kind of weird, okay? All right, so there are a couple other diseases that are kind of classic gastrointestinal diseases. The first one I'll mention is C. difficile. Just kind of a side note, C. difficile for years was known as Clostridium difficile. It was recently recharacterized, so now it's sometimes called Clostridioides difficile. I think you'll hear people say both names. That's kind of the kicker about micro. We want to reorganize things, and the rest of the world goes, no, you can't. So you might hear it either way. This is going to lead to massive amounts of watery, foul-smelling diarrhea. It's associated with antibiotic use, and I've got a whole separate video on that. Celiac disease is a inappropriate reaction to gluten. It is really only associated with people with two haplotypes, HLA-DQ 2.5 or DQ8. If you're not HLA-DQ 2.5 or HLA-8, it's unlikely that it's actually celiac, even if many people may still feel better when they don't eat gluten. But really, this is gluten intolerance. Irritable bowel syndrome. Irritable bowel syndrome, it's not really IBD. It is associated with inflammation and certain food sensitivities. And then IBD is irritable bowel disorder or disease. There are two phenotypes of that, Crohn's and ulcerative colitis. And I have videos that go into each of those. The main thing I'll say is that they differ in their location. So Crohn's can kind of be anywhere throughout the body, whereas ulcerative colitis we expect to see in the colon. And then the pathology is different as well. So with Crohn's, you're going to see what's called skip lesions, so kind of a cobblestoning pattern of inflammation, whereas ulcerative colitis is normally continuous. So that's kind of a quick overview of the normal microbiota of the gastrointestinal tract and the things that potentially could go wrong within it.